So the grand total for last week was 298 emails for the Google Doc. So I know I'm moaning and groaning and whining and crying, but the document was posted on the 21st. It was reposted again. And then when I put how many emails I had at that point, I reposted again. And I reposted that from my phone while I was at work. So, I mean, that document was there. And it's real important that you're checking announcements before you start your work, because I have no other way of giving you information if I messed up or Canvas is messed up or something is not there, because somebody was kind enough on the 21st to say, hey, Jeff, this file can't be downloaded. So I put it up there. I also spoke about it last week, and I still, after that, got over 100 emails after that. So, I mean, it really comes down to you guys stepping up, unfortunately, and really checking announcements on a regular basis. I don't, and announcements 98% of the time, I don't have you. I mean, I have an option of making you put in there that you are have. Oh, there it is. Come on now. Time. Please rewind. We might be going full screen. Okay, you see it full screen now?
No. Getting there.
Okay, I showed on my end, so it should come up.
Yes, see it.
You see it? Yay. The Starbucks I went to, my first one was totally packed. I don't know what it was, giving away the whole store, I guess. And then the second one I went to had no internet. My usual one, the bigger one, I went there, no internet. So I had to rush home, get everything going. But it seems like it may be something in the neighborhood. So let's work through this and have a good time and that. So I just need you to check announcements, please. Before you start working, every time you start working, just check announcements to see if there's anything new. Because there was a couple things I put up there. I didn't get a lot of, and didn't get hardly anything else. It's not a real big deal, but it is in the idea that I can't do anything with anything that's in Canvas. I can only give you announcements. So if you see something wrong, you either text me or email me. And if it is, then I'm going to post it on there, but I can't hit every person and say, hey, there's something else. That's why I like Populi, because I can text message everybody and it goes right to their phone and say, hey, there's a mistake. I need you to fix this. Again, we are building. This is a brand new rebuild. And I some of you may not like the way the direction is going, but if you had to do the other class, you can talk to anybody else, take the other class. You didn't get what I'm giving you right now. Okay. And it's really geared toward your DNP. It's really, I believe that you're going to be solid going in, and you're going to see the difference between what you're going to be doing and understand compared to somebody else. So let's move on. Let's see. I have not done this before. So if I click it, does it move? How do I go forward? There it is. Oh, that's a dead title. Nope. I don't want that. I don't want that at all. Come on, make me look better. Oh, that's it. I'm learning. Okay, so I want to give you a disclaimer, and I need you to understand this for the rest of the semester. I am not giving you everything. Your head would explode. You'd want to find me in the middle of the street and just take, do drive-bys. I know it because I've been there. I've been in that situation where the professor wanted you to have everything you needed to know, but I have honed it down to what I believe is the most important parts for your future. It does transcend. It's not everything. If I gave you everything that like, I went back and I did some extra studying this week. If I tried to give you everything, number one, we'd be here for 4 hours. Number two, you wouldn't remember one thing of it anyways. I need you to focus in on the topics and get an understanding. When I say understanding, it's not an understanding where you know it, because you won't. Just be okay with that. There's some people in the room that's going to bother tremendously. And I was one of those people until I finally just kind of gave up the ghost and just gave in and submitted. And guess what? I turned around and sooner or later, it became so much easier for me in the long run. Okay. So, I mean, there is something about statistics that's so, oh, why did you go there? I didn't want you to go there yet. Gotta go that way. I want you to understand that. Okay, I already don't like this. Go back to PowerPoint next week. That nothing you're going to do in this class is, how do I say this, perfect. You're not getting a perfect answer. We talked about slivers last week. This is where the slivers start to really happen. And if you put your mindset on this is one portion. So when I show you any data, that's one portion of data that could be, like when you do your DMP, you could have, let's say 10 pages, 15 pages of data. When I did my master's and I did it in quantitative, I had over 300 pages of data to go through to pick out what I really needed to do. I learned all that in 2 weeks. I did not know anything. But the one thing that my professor told me, the director told me was, you don't need to know everything. You only need to know what you need to know to be able to answer the questions that belong to you and your study. And as you do more studies, you will get better at them as you go along. So if you keep that in your mind, that there's no definitive answer, there is a conclusion, as we did last week. And a lot of you did really well. But I'm going to tell you, get off the thing of writing everything. Okay. The answer to that was, the men believe that men believe they choked in competition. You don't talk about the women. I'm going to say it this way. It's not true. We don't care about the women. If you go back to what the topic was, it was the experiences. Which gender, if I put it in simple terms, which gender believed they choked more in competition? So if I said the men, I'm a scholar and know that the women were lower. So I don't have to add in the ending. Okay. Things like on the average, that's extra. First off, you don't have an average. You had 30 people. How do you average 30 people? You're going to get a mean that's an average, but that's not it. It's very straightforward and direct. Now, the second one, most everybody put in the women. And if you looked at it, it read well. So when you read it, did it read well? Now, you may have thought the first one read well, but that was set up for you to, I guess, to fail and write women so I could train you to just look at it and say, this is a difference. We need to go here. The second one, a lot of you, some of you, I told you take out the women, some because of how you wrote it. Okay. So you only want to convey what you need to convey. And the opposite side is like an inference. So if it's men and women, let's switch it up. The women are smarter than men. Okay. You say the women scored higher on this test score. Do you say women scored higher on this test score? Period. Because you leave out a place for somebody to question your data. One word can do it. Now, as we move into this, again, some of this stuff, I'm showing it to you. Okay. I'm showing it to you and I want you to kind of become familiar with it. We won't be doing it in class. Some of this we won't do in class. It won't be a part of your homework. Only certain things will be, and that's fine. But I want to give you the big picture on the assumptions. And I'm not going to go through all of them. I'm going to talk about them to begin with. And then I'm going to really work on normalcy because that's one of the bigger ones for the tests that you guys are going to be running in your DMP. There are other tests for normality and tests for assumptions in other tests that we will discuss on that week, or I'll be here forever. So I'm done. I got to get off the soapbox, or we'll be here forever anyways. There are two types of tests. There are parametric and non-parametric. Parametric tests have a more rigid and solid set of rules and standards that you have to go by. And I'm going to my book so I don't forget anything. Now, I have this book here. It's called Discovering Statistics with SPSS. If your children ever have to take a serious SPSS class, this is the best book ever. It's 5,475,000 pages, written by a guy. I think he's English. I can't show you the videos because we're at a Christian university, and sometimes he doesn't say things that are really proper. But the book is set up in a way that a layperson, it's the only reason I got through statistics, because it's layman's terms. It talks about real things in real life, where a lot of your book does a very good job. It's probably the best book I've ever seen. This is a book, if you go to have to do serious advanced statistics, walks you through every step of the way, and it's written in human terms. Okay, so, and those are always good. So in those tests, we have a non-parametric test where we have 4 levels of in true actuality. There's a couple little nuances on different tests, but first one is normally distributed. We're going to get into that a little bit. Homogeneous variance, that will come up in a later test. In a later test, we'll do probably, I think it's week 10 or 11 or something like that. Interval data, you should know that from your notes. And if you don't, I'm going to send you back there to know your notes. And that's like, even the book says, that's kind of common sense. Okay. And independence. This assumption, like that of our normality, is different depending on the test you're using. Okay. In some cases, it means that data from different participants are independent, which means that the behavior of one participant does not influence the behavior of another. Okay. So just think of the idea that when you're doing the test, something else doesn't influence it. Okay. So let's say in these 4 that we're going to talk about normality. So it doesn't meet the criteria for normality. Now we move it to a non-parametric test. And what the funny part about the non-parametric test, in the test that I'm teaching you, it's the same test. The computer does something different in the formula and sets it up to where you're getting it and you have a different, like the x2 for a chi-squared. But what it does is it points the person reading it to saying, oh, the data wasn't normal. You would also say that the data wasn't normal. That's why we're doing the test. Okay. And you can read all that, but it's basically parametric runs on these tests and non-parametric runs on these. We are going to spend most of our time in the parametric testing because you're going to be set up for success in your DNP, whether you believe it or not, you really are, in terms of the kind of data that you're going to look at. So like 1 week last semester, we spent the whole week talking about missing variables. First off, if you're any kind of a good professor in a DNP or a dissertation, that you're not allowing that to happen, because it's a whole lot more writing for nothing. And why do nothing for nothing? If there's no data for the person, there's no data. So why do I need to have that person in there? I go find somebody else. So there's just so many little things that can be talked about here. So assumptions, I kind of went through that, but the biggest thing is when we do this, it shows validity. Okay. Think of it this way. Everything's a probability. So it's a probability that it's right. It's probably wrong. And a lot of you noted that when you talked about the hypotheses and how crazy the type 1 and type 2 is. It may be true, but it may not be true. That's where I kind of point to the idea that you don't have to be perfect in statistics. You're reporting whatever you have. And then they give you all these things to back you up so you don't basically look bad. That's the bottom line. So if these assumptions aren't there, can run this test over there and it's going to automatically be valid. But I got to look at this to get this. Okay? There's things like effect size. There's all these different things. And these are all kind of funky words that you should have probably, a lot of those were in that first week. And that's why I say really study those words. You don't have to memorize them, but they're going to come up. And what I'm doing these weeks right here are setting you up for success for the next ones. Because if you even relatively understand some of this stuff and you take your notes and you're doing what you need to do and you answer all the questions, you're going to be strong enough that when you go into this, you're going to know how to do the conclusion. You're going to already know that you're going to have to do exactly what Jeff tells me to do. And then I'm going to do an analysis. I'm going to turn it in early in the week and he's going to tell me if I'm right or wrong. And if I'm right, I'm done for the week. That's as simple as I make it. Last week, last semester, I took 2 hours and a half every Sunday trying to work through the data that I got. That was the first time I did it. I don't want you to do that. I want you to focus on it and getting the wording right for your DNP. Understand what that story is all about, and be able to draw a conclusion from it. You can draw one conclusion from each of them. You can draw 100 million conclusions because you're going to start to begin to see it. Okay. Be okay with making mistakes, because mistakes make you stronger, not weaker. Okay. Now, if you make the same mistake 50 times, that's a different story, but we don't do that here. We're smarter than the average bear. Let's talk about normality. Okay. So I could say that I am not normal. I'm kind of abnormal, kind of crazy, if you haven't figured that out yet. But when we're talking about data, we're talking about it looking normal. So this is the point where I tell you that there's two different sections here. The first section is that I could look at the numbers. There's numbers that tell me exactly what it is. The answer. Is it normal? Is it not normal? Okay. But then I look at, and if it looks a little off and I look at the picture and I say, oh, that looks normal to me. And then you could have a slightly normal, slightly non-normal. You know, there are a lot of things in there. That's, like I said, it's not an exact science. It is a probability that this is correct. Now, this is data sitting right in front of you. Now, this one right here was just basically taken from the internet. This is what a normal distribution looks like. A professor in college, in my doctoral program, said that you got a better chance of winning the lottery than getting normal distribution. A perfect normal distribution. And this is not truly perfect. It doesn't go all the way up. It kind of goes up and goes down a little bit, and it goes up a little bit and it goes down. But you see the curve in there, that bell curve, that is normal. It's in the middle. Okay. The data or residuals or errors in the model are assumed to be normally distributed when you get something that looks like this. Okay. All right. Moving on to the next slide. Everything works like it's supposed to. Now let's talk about skewness and kurtosis. Okay. Crazy words. These are crazy stat words. Okay. So in the idea that this is visual, just as you're doing the graphs, and that's why these two are together this week, because this portion is the same idea. I don't have to go over it again. We have numbers and we have pictures.
Thank you.
So, you're welcome. You have numbers and you have pictures. When you look at the numbers, you could go, I really don't get it, but I can look at the picture and go, oh, that's it. So when you look at the data and you go back, think back to that last picture that we had. Okay. That was a normal distribution, kind of like in the middle here on the left-hand side under skewness. Okay. Normal distribution, no skew. Mean, median, mode are all in a close. I'm going to always say close to the middle. If it goes left skewed, which is basically, if you're looking at it, it's all, I look to the right, but I'm really talking to the left. Okay. And vice versa. The blank is on the left. The curve is on the right. The mean, mode, and median on both sides, whether it's right or left skewed, one's positive, one negative. I don't worry about that. Okay. But you'll see how the mean, mode, and median all go to a different place. And you see the mean is farther away from that middle, more the median or the middle of the section, middle of the curve. Okay. So when you visually see it, you can go, oh, it's to the left, it's right skewed. Okay. And now you're out of normality. The left skewed and the right skewed are out of normality. There are things like you can run a transformation, and then it will, but with the transformation, it will turn it into a normal distribution. We don't have to do that. You won't have to do that. I just mentioned it. We moved on. So now we have which way it goes. Now the kurtosis, now that is the shape of it. Does it have a very high peak? Is it mesokurtic and it's kind of in the middle, or is it platykurtic? Now, those of us that know what a platypus is, think of the snout of, I think it's a snout of the platypus is flat. That's flat. Lepto, I don't have no way to do it. Meso, it's kind of like, it's just kind of like the rolling plains. It's right in the middle. more of your normal distribution is going to fall into the meso. It can fall in the lepto, and it can fall in the platychuric. But when you look at it, you'll be able to see. Now, this, in all of these, wherever you see the peak of the curve, that's where most of the data is going to fall. So the data can fall all the way along the continuum there. So if it's really spread out, it's going to be platychuric. If it's kind of like what we saw in that picture, the first picture, now it's mesochuric. And now, if they're all bunched up in the middle, and it'd be leptochuric. Now, if we're talking about the left and the right skew, a lot of times you're going to end up with a leptochuric because a lot of times it's going to go to left, and that's going to be a very high peak. Now, you see where it says kurtosis is greater than 3, kurtosis is equal to 3, and kurtosis is lower than 3. We'll come into that later, but that's really the number. Now, on the skewness size, we're looking at 0. And why is it 0? Because the normal distribution would give you a mean mode of median right in the middle, and they consider that a 0. Now, that mean mode of median could be any number of data points, but the middle would be almost dead center. I'm always going to say almost because hopefully you'll understand that as we go along. Okay, so for the kurtosis value here, there we go. Faces out of the way. Mesochuric 3. You see greater than 3, less 3, kind of like the same thing. I just made it bigger because that's really small. Okay. And we're going to look at data, so don't be surprised. Okay. So can somebody chime in and tell me, is this normal or not normal?
Not normal.
Thank you. Thank you. Thank you for jumping in there right away, too. This test was on length of stay, and this is data that we used last year. And this is where my problem comes in, because one of the questions was, is it normal? And every week I told them, guys, it's not normal, right? It's not normal. Okay. Somebody chime in and tell me, if you looked at that, other than the factor that it's over there, what would be something you could say that it could look normal? What looks normal here?
The mode.
Nope. Say with the picture, not a number. So to keep going, does the bell curve kind of look normal? It looks normal, but the visual of that is pushed to the side. So would this be mesochuric, platychuric, or leptochuric?
Meso.
Sorry.
I'm going to say plato. Plato,
Why do you say plato?
because it's wide.
No, it's not. Look at the bell curve. Does it look high? Not the data. Does the bell curve look high, medium, or low?
Medium.
Medium.
So meso.
Medium, meaning mesochuric. If that was up closer to the 40 or the 50, or if that was even lower, it does. And I will go back to the platychuric was a great answer due to the factor that everything is so bunched together and it's a little lower. But when in a true platychuric, it's going to be very shallow. And a lot of time the data is going to be really spread out. The data is not really spread out here. Okay. So this is, you see the visual. Okay. So the kurtosis is 55. Does anyone remember what the kurtosis is supposed to be? 3. That's 55. It's automatically, you're going to know that it's something. The kurtosis is off. It would point more to truly a leptochuric, but you'll see that the data is distributed because there's not a ton of data. So there's a lot of factors going in it. So if you were to say leptochuric in your paper and show the number of 55, you would be correct. If you were going to show the visual here, you would probably say it was normal. I mean, I'm sorry, mesocurtic. So like I said, it's not an exact science. It's what you visually see on the page. Okay. Now we add in the number. Now you can point it toward leptocurtic because the number is high. Anybody have any questions? So now we go to the skewness. Now the skewness is supposed to be 0, correct? Is this a positive or negative number?
Positive.
Perfect. So, in essence, it is a positive skew. If that number is negative, it's a negative skew. But if it's negative, the numbers would be on the opposite side. Okay. So the numbers tell a story, but the visual tells you a story. Okay. So this is the difference of what this is going to be one of the ones you're going to do. So, is this normal?
Yes.
Perfect. Okay. Looking at the kurtosis number. Okay. Where would you put it? Meso?
Lepto. Huh?
Okay. Remember now, kurtosis. If it's 3 exactly, it's perfectly kurtosis. If it is above 3, it's lepto. If it's below 3, it's plateau.
Yeah,
So,
Plateau.
lepto.
Oh,
No, you're right. I'm sorry. I
Plateau.
apologize. Whoops. My bad. Bad professor. Okay. Take $10 out of my paycheck. Here's the deal. That's right. It is below 3. I'm sorry. It is below 3. But are you closer? You're closer to normal. You're closer to meso than you are to plateau. So if you said plateau, you would be correct. If you would have said slightly meso, you would be correct. So it's how you visually see something. Because it's still pretty close to 3. So the closer you get to 3, the more you're close. And either way, if you wrote it either way, it would tell the reader, and that's what you're doing, is you're telling the reader what you are seeing. As I said, not an exact science. The skewness is 1.02. So are we normal? Are we positive? Or are we negative skewed? Left or right, positive, negative? This is a tough one, and I put it there for a reason. So let me give a guess.
Right skewed.
And you're right and you're wrong. Okay. If you look at it, does it look relatively normal?
yes.
And that's what you go with. That's what you go with. So if this was in your DNP and you had that number and your data looked like that and you had to put it in there, I would put them both in there. This is why I said it's not something you have to fully understand. It's something that you can, if you can visually understand a little bit of it, you are dangerous. Because if you were to do this a whole bunch, it would all, you just see that it just works that way. It just works. And this was hard for me. And as many years as I've taught it, this is the way I teach it, because I want you to understand that it's not exact. And it can't be exact because the number is 1.2. Okay. But we look at the other one was 55. Okay. Or 6. There's a big difference. So we could say relatively normal, and we would, as long as it was relatively normal, we could stay with the parametric test. So all your answers are correct. Just know that it's not there. So I'm going to show this for this, and then I'm going to move into an actual SPSS data set that I ran everything, and we're going to run through that real quick. Oops, sorry. Press the button again. Even though you have skewness and you have kurtosis, these two tests test for normality. And it's nice. SPSS tells you right at the top, it's a test for normality. Okay. The Kolmogorov, Samirov, and the Shapiro-Wilk. Okay. Each run differently, but they give you the same actuality. I'm going to give you a kind of a tutorial on p-value right now. Very short, very sweet. We're going to dive into that next week because it's so important for you to understand that as you're moving forward. Okay. When we say p-value, it's the probability value. It also equals out to the word sig, which is right here. This word right here, sig. Okay. And you'll see that number right here. Okay. As you're looking at that number, our value across the board, unless you're given a different number from your DNP professor, is generally 0.05. Okay. And I'm not going to get into details on that. I want you to remember the word. Get that in your mind. That's a major thing for you to remember is 0.05. It can be another number, but for us, it's always 0.05, not 0.50, not 0.50, not 0.05. It's 0.05. Get it in your head. That's a 95% chance that it's found by chance. In these tests, it's a 0.05, which either is going to tell you significance or non-significance. So let's go back to hypotheses. And a lot of you said, we are looking for a significant difference. Okay. So if the difference is off by a hair, you can't use your hypotheses because you're giving a direct statement of what you're looking at. So the word significant is a huge word, and that's one of those words when you put it in there, it changes everything. All we care about is a difference. In this one, all we care about is it above 0.05 or is it below 0.05? Okay, so let's take this number right here. It's the third one over. It says sig. Can you see that blue dot?
Yeah.
You guys have a blue
Yes.
dot on your screen?
Yeah.
Okay, good. You see this number 2.200? Is it significant or non?
No.
It's not. So it's non-significant. Remember, you always want to try and use the keywords and you become accustomed to it. It's non-significant. So if that number is non-significant, then we can expect that there is that it is normal. Okay. If that number is below 0.05, then we can say that we are probably we don't have normality. So as you can see, there are multiple ways to get to your conclusion that you need of what you need to do. So this test we could run, well, we already did. We could run this at whatever test it is, and basically it would be valid. The only way it would not be valid is if the data is bad, you lied, whatever. That's the only time. We have enough information here. If we were to put this all on our paper and point to it, nobody would question it. Nobody would question it because you've given them what they need. Let's say we generally don't give the histogram, but we know that the histogram is normal, relatively normal. We now know with the test of normality that it is normal. We have the backup to go to that. The skewness and the cortosis are kind of a vague way of showing the shape of it. That's why you can use different words based on what you believe that number actually equates to based on what you did, but you always want to go back to the visual and say, okay, look at these. Okay. All right. What's the next one? This is where I kick out. Yeah, this is where I kick out. All right. So close this one down and to the Word document should be so right here. Okay, everybody see the Word document on the screen? Now I'm going to move through this one really fast and talk about stuff. Some of it we've already talked about. So if you were to have to do this whole thing for your DNP and you're using SPSS, which 90% of you will use SPSS for that. This is the descriptives, which you're going to be doing descriptives later, but this is everything descriptive. So you'll see here in this one, we're looking at the percentage of SPS on an SPSS exam and a numerosity. numerous. I don't know how to say that word, but the numbers. Okay. You'll see that the mean is there. You'll see that the confidence interval is there. You'll see variance is there. This is everything that you need. Here's the skewness and the kurtosis. Okay. Then you got the same thing down here. You got the same thing. And then this is basically on 4 different, it's on the 2 variables, but Sussex University and Dunstan University, which I bet you he made that up. Okay. And you'll see that now we have the test for normality. So we've got the sig right here and the sig right here. And you can see that these up here are just like the other one. The Dunstan was here, but guess what? This one down here is below. And that's why I really like this, because this one is lower. So it's truly not normal, but we haven't gone. We did it other way. Now we're going to go and we're going to look at all these things, and it's going to, there's different ways to show visually the things are normal. Okay. We have our histograms. So here's the histogram on Duchess for the percentage on the exam. And then here it is for Sussex. And you see it's a little more left. And the numbers before kind of prove that. Now, this is the stem and leaf plot. Okay. I'm not going to go into too much detail. Honestly, this is another visual way. And if you can see it right here, this right, how you can see it's almost like the bell curve, and there's more at the 10. It's another visually way that actually gives you how many. So like there was 3 that put in number 4, and there was 2 that went number 1 and 2 that went 0. But you can see how the curve works. And it's the same as above, but this gives you just a tad more information of where the numbers really lie. Okay. And then you've got the same thing here, and it's going to keep going. Now, this is a QQ plot, a normal QQ plot. And what it is this is the expected normal. And basically, this is like what we call the best fit line. And you see how all these little dots there, all the little data points, and those are observed values. All those little data points are right near the line. If they were all over the place, it would then again show you. It would show you exactly that your data was not normal. Now we keep going, and it's going to happen again. And it's going to be relatively normal. And then we have a box plot. Now, this is not the best box plot, but this is another way of doing this. And this is, for me, these are interquartile ranges. So this is like 75, this is 25, and this is your top score and your bottom score. This is the line at the top and the bottom, or top score and your bottom score. Now, if there was a little dot right here, and let's say that number was 55, that is what we call an outlier. It is a data point that is way far away. So I would imagine, I'm just gonna guess, and I'm probably wrong. Let's say we have people in here from 23, 24 to, let's say, 35. Okay. And let's say I enroll in the class. I'm going to be 62 in a couple weeks. I'm an outlier. I can mess up your data completely. I can skew it to the left and right. So what happens here, and this is the point you make, to make it valid, yes, you'd probably throw my data away. You'd put it away. You wouldn't use it. Okay. But the thing is that I'm still an active participant. So when you write your paper, you would say that there was one outlier that was 62 years old, and in examining the data, it was, I'm just going to use layman's terms, better to not use this data because it skewed the results. And if you have a whole bunch,
what if there were 10 62-year-olds? Is that number?
Now it all comes down to a decision as you look at your data. If you took those out and ran the data on just those, and you had enough to make it valid, which is basically 30 participants, you might not use them, or you may just leave them in there and run with it. But you would always explain those. Those are called limitations, and you would explain the limitations of the age gap. One of the limitations would be there was a huge age gap between the top of the young people, and then the older, the more mature participants. So you would explain what you did and how you did it. So that's what it really comes down to. That's why I said it's not exact. You take a look and you take out that data and say, is this really what I want to look at, or do I want to look at the whole thing? And if you want to look at the whole thing, you write it that way. But you, in your paper, you would tell people exactly what you did and why you did it, and then it becomes all good. Now, somebody else may not like it, but then it's their job to this being everything and quantify, because your methods you're going to go through and write out exactly what you're going to be doing. You would go to your methods. They would go to your methods and run the same test, but they'd only get people within a certain age range. Now, for me, when I would set this up and I would do the methodology, I would have you put down criteria of what it was. So it'd be 24 to 34. And if it was 62, you just wouldn't let them do it. You wouldn't put yourself in a position to have to make that decision. And that's what a good dissertation professor does is, oh, no. You're not taking from 23 to 64 or 23 to 90. You're going to hone it down and you're going to stay and you're going to get people within this range, because we want you to be successful. If you had one and you want to leave it, it wasn't that big of a deal. And I looked at the data. I said, it's not that big. It's not going to make that much of a difference. So like one person saying one thing or another one time doesn't change everything. You had a bigger group, yes. But if you're dealing with 18-year-olds and you got one 62-year-old, I probably would dump it. And I would just put in limitations or in there saying we had one person that was much older and we did not use their data. That's it. Okay. So then there's one of these for each of them. Okay. And then here's the more histograms. Now, I didn't run this, but this is the first one were normal. So we look at this one and we can say it's not normal and it's skewed. And when we look if we were go back and look, that's where you got those other numbers from the Wilks and the Shapiro. It confirms it. And there's a way in SPSS to put in the normalcy line right there. And you see it's to the left. And then you go here and you're going to see this one's to the left too. In this case, because this is a paired sample t-test, you would probably not run a different test for this one. You would note the difference in the normality of them. You can't run like paired sample because it's two sets of data. Okay. So you got to run it a certain way, or you go run it a straight non-parametric. You're going to get this. Actually, you're going to get the same look. You're just changing the test and how you write it up. Okay. So in the idea, if I bring this into a summary of this is one way of dealing with an assumption. Okay. And multiple ways of looking at it. And that's the part of statistics when I took my undergrad that was not really even given to me. And we didn't ever talk about assumptions. We went through whatever what test was, and we went out and did all the numbers, and then you got all this stuff, and I still didn't understand what it meant. And then when I got deep into this, now the idea is it's all about analysis. Yes, there is a steps to get to this point. If you do it right, your analysis becomes the most important part. And I'm going to tell you that this, for me, is probably the most important part of your DNP. Because when it comes to this point, you're going to want to be done. And if this becomes easy for you, you're going to fly through that and go, I see this, and I see that, and I see this, and I see that. And remember, you're going to have slivers of stuff. And then you're going to have to sit down and kind of coagulate them and see what really goes together and creates from those simple conclusions like last week into what I call grand conclusion. So I'm going to give you the idea of how this works. Is my very first class. The last time we did anything with any question with steroids or drugs, we're not marijuana or anything, but just any kind of steroidal or in athletics. So they asked 3 questions. And one of the questions was, Do you take steroids? That was a yes or no question. Okay. Do you have I'm trying to remember them now. Do you take steroids? Are you here it is. Do you take steroids? The answer was no. All of them, all 45 of them, no. Do you believe that you need to take steroids to go to a Division I college? The answer was yes. Okay. And then the last question was, are you being pressured by your by a coach, a parent, or another player to take steroids? And the answer to that was no. Okay. Those are very simple and really demographic questions, but turn in, and we'll talk about democratic. Those are three very simple yes, no questions that really put a vein for his discussion. He had to do 10 pages for his discussion, and it turned into 4 pages because he talked about the one, he talked about the second, he talked about the third, and then come up with a grand conclusion. Because if you think about it, they're not taking steroids, which is great. They're not being pressured. But even though they're doing those two, they still believe they need to take it, and they're not taking it. So that was a grand conclusion of 3 slivers altogether. So the analysis of what you're doing, first making sure your test is valid and making sure everything's right, and then you run your test, and then you get your thing, and you know it's right, and you know it's valid. You take one sliver and talk about one sliver, and then you've got these other slivers that you can all put together, and now it turns into a couple pages that are dynamic. Those little slivers are significant. So I could write 3 lines. Nobody took, or I can write 1 line. None of the participants took steroids. Isn't that great? But you put those with the other ones, and now all of a sudden you draw a picture, and that's what you're really trying to do through the rest of the semester. When we get to after the midterm, you're really looking to have the flower blossom, and it's a great picture of that one portion of a test. You won't understand anything else about it, but it's that one portion of the test where you can say, if you looked at it and you went from the beginning to the end, you be able to look at another one and go, okay, this is this. Oh, I see that number. That number works. That number. Oh, I see that. Okay. Oh, that's easy. Test scores were higher for men. Done. Okay. So that's that portion. It's 51. I need to, are there any questions? Are there any questions?
Yes. Do we calculate the skewness and then kurtosis? Is there like a equation that we have to calculate those numbers?
If you do, let me know. Show me. If you use an SPSS, it does it for you.
Oh, okay. I see.
If you use an Excel, there's a thing in there that says skewness. We're not doing that. This is the moment where I'm teaching you about normality.
Okay.
So just if you came in late, a lot of the stuff I'm giving you, we're not doing. It's still very important to your future endeavors, because I don't know what they're going to ask you to do at that point. And basically everything came from an SPS, came from one test. Everything you see on this page came from running one thing in SPSS. I went to Explore, I opened up the boxes, I clicked the boxes, and I did it from the book. Followed the book. Okay. And I clicked all the buttons, and everything popped up. All the histograms popped up. All the other stuff popped up. And I just basically quickly went through this and said, do this. Okay. So let's see what else. Any other questions? Stopping my share. I'm back. I'm back on my beach. Okay. So we talked about last week. We talked about the drawing conclusions. Okay. If we talk about the graphs, if some of you had to do edits, it because you just missed little things, and that's okay. I have no problem with that. It doesn't take me long to send those back. I'm sorry you got to have edits, but I mean, and honestly, I forgot to say is if you don't want to edit anything, then tell me you don't want edits. I'll give you a grade. One thing I don't have to do. But I want you to understand this material. So that's my pitch. The next part is the other part of graphs. I'm not going through each graph. Pretty self-explanatory. Okay. The book goes through a lot of it. And that if you could put it all into one document, that would be great. Okay. I don't need fancy. Just like the graphs last week. Some of you did the video and did the crosstabs. And I didn't catch that right away. So I made somebody do it over and I apologize. And then I gave you the stuff on Tuesday night. Both ways are correct. If it looked like a graph with everything where it was supposed to be, I didn't care what the words were. If it had what it was supposed to have, it was fine. If the lines weren't in the right place and it wasn't what it was supposed to be, that's when you got to edit back or you got dinged. But I think for the most part, I'm pretty clear in the video. If you're not watching this video, I don't know what to tell you. Because you're kind of like on your own in the book. And when we get to the other half, you could probably not come to these and just do the stuff out of the book and you'll be fine. But more of you did the beginning of the week and more of you got 100%. And that's my whole goal. I want everybody to have an A. But you got to do it. You got to get it done. You got to get it done on time, guys. Okay, that's number 2. The charts. Feel free to reach out to me if you're having trouble with one of the charts and that's fine. But I don't need it fancy. I need it to look like a pie chart. I need it to look like a bar graph. I need it to look like a line graph. Okay. If you're unsure, go to the internet, put in line graph. If you have ChatGPT, show me what a line graph is in statistics. It'll give you an example. It'll send you to other websites. Okay. And the reason why I do it that way is because every test has something different. Okay. When we get to that other side, the only one you're going to be doing is a scatter plot. But I need to know that you know how to do each of those so you can just take care of business. Somebody says you're going to do a pie chart. Oh, I know how to do a pie chart. And if you're on SPSS, graphs, pie chart, move everything over, run the thing, boom, the pie chart shows up. You get fancy and put all the other stuff in later. That's easy. You can figure that out. I figured that out for class in about, not this class, but in other classes in about 8 to 10 minutes. And worst case scenario, and I didn't do it right. I went to the YouTube and I said, pie chart with labels. And it gave me a 2-minute video on how to put the labels in there. Just, you got to use your resources there to be very efficient. And so if you can take them all, put them into one document, that's even better. I just go down, I'm going to look, do they all look right? Is everything where it's supposed to be? Boom, you're done. So these aren't supposed to be hard. We make it hard. Follow the directions that are there, follow directions in the book, get your pie charts. Okay. And that's about it. Is there any other questions? I want to go to the room real quick here. I can go here, can't I? So looking ahead to next week real quick, and then we're out. Can't believe we're already in week 6. We're getting into central tendencies next week. Okay. And that's like the mean, mode, and median. And you kind of got a little bit there. We're going to talk a little bit deeper. To me, there's a quiz next week. It's, open book. Take it 100 times to get it right. Okay. Don't stress. Okay. Do it early in the week. Get it out of the way. Do your discussion board here in the reading and the discussion. Go through the notes. And if I'm correct, I think I have some other stuff in there. So central tendencies, I think this might be all next. Yeah, that's it. Central tendencies. We're going to go into the mean and the mode and the median and some of the stuff we never use, but it's there. And then we move into the last week, which we're going to go back and create more hypotheses and we're going to really dive into the p-value and how the p-value works for you to answer your hypotheses. You already relatively know how to set up the thing, but now the p-value is a very big component for your write-ups and can create you a whole lot of havoc. So this is the point where I tell you that, again, even in the p-value, there's another way of getting the p-value. There is the p-value that's 0.05 above and below, or you can do the critical value, which is something else. And then you go to this chart and you got to move your lines around and then you make a decision after that. There's an easy way and there's a more difficult way. I didn't say difficult, but there's a more movement. I like simple, direct, to the point. But if you understand what it is and you understand the difference between significant and non-significant, when you go to write these, it's going to make sense to you. And you're just going to go, oh, that's the deal. I'm going to write this. Okay. And I'm going to write this. And you're going to do the same thing every week. So as soon as you get it, and as soon as you understand the difference between difference in a relationship, and a lot of you did pretty well last week, when we get in the other side, that's not going to be a factor. It's going to be a factor. Can I follow directions? Can I get everything in there? And can I begin to start to understand what those words mean? And then I'm going to be able to draw great conclusions from that. And then after that week, we have this week, that week, and then the midterm. And the midterm, I'm going to tell you right now, the midterm is derived from the notes, nothing else. So if you have your notes and you're continuing studying your notes for your midterm, you will have absolutely no problem because it's all on the notes. Didn't come from anywhere else. Didn't come from an outside source or anything. As you can tell, I'm not into tricking anybody. I always hated that. My first biology teacher was called Flunkin' Duncan. And let me tell you something. He flunked everybody. You had to be brilliant already at biology in the 10th grade because the test had nothing to do with what he taught in class or the labs. Don't know where it came from. Didn't come from the book. Didn't come from anywhere. So unless you were a science genius in the 10th grade, it didn't happen. So I always vowed if I ever became a teacher, that would never happen. And I've in 15 years, that's what it is. So any questions?
Dr.
With the assumptions discussions that's due on Thursday, are we supposed to choose a graph and then like a bar graph, for example? And
no, go to the book. Go to the book, and there's an assumption for every test, like the t-value and this and that. Find one of the tests in there. So, do I have my book close by? Yes, I do. So, if you go to the back, you usually say it, but if you go, and each chapter is a little bit different. So, let's stay away from linear regression. Okay. So, let's say we're looking at where is it? I'm going the wrong way. Maybe I should just look at my tabs. So let's say like on page 217 of the book, it says t-test for independent groups. And you go back, there's t-tests for one sample t-test. Those are the tests you're going to be doing in the second half. Okay, guys? So you go in there like 217, it'll say assumptions. And the following parametric assumptions should be met before the independent sample can be computed. So tell the test and then go through and answer the question. I'll be honest with you. All I want you to know is, in all honesty, is can you find it in a book? And can you write it? Because then you're doing something repetitious.
Okay.
I don't remember what the actual questions are right off the top of my head. Okay. Somebody has it, split it out. Let me see if I can find it real quick.
Choose the assumption, note the assumption, define the assumption, describe the test available to validate the assumption.
There you go.
Okay.
So you take what we talked about tonight, not everything, okay? But I would stay probably with an independent sample t-test or let's say the, what do you call it, one sample t-test? I don't care, everybody does the same thing because you got to post first anyways. But it's going to be right in there, okay? So like variances in the group to be compared, okay? So I'm going to give, let's say if you're doing this, so I'm going to give you an answer. Somebody give me the answer to what would you do to find out the variances of the groups being compared? I'm gonna do it. Dun, 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 dun. Let's see who's my hero tonight. Silence is scary.
Would you just subtract one value from another?
Nope.
Oh.
But you're on the right track. How about if you look at the word variance on your SPSS? It's going to be in the data. If you're doing Excel, you're going to run the formula for variance and get your answer. See how see what I'm talking about being simple? Simple. If the only way you can find the variance is to have the variance value. So real quick, because I want to let you guys go. I'm going to share my screen real quick. This is where I'm going to tell you that using SPSS is really cool. I'm not trying to turn you away from Excel if you're an Excel person. But look, can you see it on the screen right here? There's the variance. I'm not asking you to be able to really say what that is, but in terms of this, I would say, oh, that variance is really high. That variance is really high, which means everything is pretty spread out. Okay. Okay. So look at it and do your best you can. And I'm going to be starting in those probably tomorrow. And know that you need to get in there and respond if I leave you a question or something, or tell you a different direction to go. Okay, because this is, you know, it's kind of like it is. The discussion is actually harder than the rest of the work. So it's the idea of think about going back. Oh, I think that's page 135. If I'm correct, it's not. Assumptions. Oh, the assumptions of paramedic test starts at 147. Okay. And it talks about what the assumptions are, and that you can also look up the word variance in the back of the book. Sorry. Just messed up. So like variance, you could go to 24 to 26 choices, statistical text, and level of measurements. So using the back of the book to get the answers for here, and then basically just give it the best answer you can. That's it. Okay, because I really want you to use your book to get trustworthy of the book, because the book is amazing. It gives you about 95% everything you need. I probably would have passed statistics with a higher grade with this book, because nothing's vague. Everything is right there in front of you. It gives you what you need. It's not secret. Okay. Any other questions?
I have a question,
Shoot.
on the assignment for the graphs, that's due on Sunday. We just pick one data file and then.
No, all of them. You have to do them all.
I have to do all the data files.
Yep. If you're doing an SPSS, just leave your output file open. It will put them all in there, and then all you have to do is export it.
Okay.
Now on the Excel file, it's one file, but all of them are in there. You've got to do one for each one.
Okay, so pick a data, I'll do all the data files and then pretty much do the 7 graphs that you posted.
Are you using SPSS or Excel?
SPSS.
So when you just keep opening a new one.
Okay.
So you see this output file on the screen?
Mhm.
If I go up here and I go to graphs, and I don't know which one to use, so I'm just going to grab histogram. I just go to histogram, and then it's going to bring up whichever one I'm working on.
Okay.
So let's say I take percentage of lectures, and I take this and I throw it out, and this is not going to be good, but you'll understand. And then I go here and I go here. And then sooner or later, it will put it at the bottom of this one. So make sure this is empty. It's real slow. Come on, let's go. So in the end, it's right there. It's normal. Oh, cool. So it'll go here. Now, if I go back and I open up the one for the pie chart, And then I go here to graphs. Come on. I think I'm frozen. Guys still there?
Yep.
Yep.
So if I go back to graphs and I slide down and it says pie chart. Let me see if I do this. Oh, there it is. Graphs. Sorry. I go to graphs and then I go to pie chart. And summary of the groups of cases, define, yes. Now I'm going to define it. It's going to give me the box sooner or later. The box. And then I put percentage of cases. No, number of cases. And I go here and I put it here. The variable is percentage. It's not going to, oh, define slices by that. And then I can throw them down here. This is not the one this is not the kind you're doing. And then I hit here. And I'm showing you this, even though it's probably completely bad, that it'll just put it right at the bottom of the output file. Sooner or later. When you do the Excel, if you highlight it and ask for the pie chart, it will give you the pie chart. See how bad that is? So, but it will put it all in one. So just keep opening the file. Yep, opening the files, put them all on the lab if you're using lab, and then just keep opening those files, keep putting in the same output, export that one output file to Word, and you're done.
Okay, so each data file, which there's 5 of them, they're going to have 7 different graphs.
7 different graphs. There's 5 files, right?
1, 2, 3, 4.
Yes.
There'd be 5 graphs.
Oh, I think the last one is asking for a stem and leaf plot, histogram, and something else.
Oh, you're totally correct. Yeah. You just go through and do all 3.
Okay.
It'll end up, you're correct, totally correct. It's 7.
Okay.
Totally
And you know,
7.
for people who are doing Excel, the stem and leaf plots, we have to do that in SPSS.
That's a very good question. I don't know.
Oh, that's what I read in the book. That's why.
If you do, don't worry about it.
Okay.
If you do, because if you're not using it, if you're going to use Excel, then use Excel. You're good.
Okay. Gotcha.
Okay. So I'm going to put out an announcement and see how many people hit me up.
Simon says using your preferred data file. So I understand that pick a data file and then create the 7 different graphs. That's how
I'm going to tell you something. If you do, it won't work.
Okay, so I'll have to use
There's a data file for each one.
each one. Okay.
I didn't write that. I didn't write that. So I'm going to tell you right now, I need each file has a graph, because if not, the graph won't come out right. Those are set up that if you do the steps right, you're going to get a pie chart that looks normal.
Okay.
Anybody not, is that not clear? It's okay if it's not clear.
I'm
I'm gonna go to the classroom real quick. Hold on.
Yeah, it's not clear. I don't know why I'm having.
I'd rather you say it's not clear. It's
not
important.
clear.
It makes your life easy.
I
Graphs.
feel like you're going to get a lot of just.
Hey, it is what it is. After this week, anything's possible.
Yeah.
It is what it is. I'll work with it. Download the data file for either Excel or SPSS. There are all the data files. It's exactly what it is.
Okay, so I see 5 of them.
Use the preferred data file. That's either Excel or SPSS.
Oh, okay. Gotcha.
Which is not clear, which I will put it in the notes to get that cleared up. But yeah, each one of those, you're doing each one of those, and each one of these works within it. And that's really not clear, is it? Okay. bar, scatter, pie, line.
So if I open the data for anxiety, and then I say, I want a bar graph, and then it'll make a bar graph? Is that right?
If it doesn't, let me know, because it'll be the first time I've ever seen it happen. Hold on. I'm gonna do the line graph for, oh, I didn't want to do line graph. Let's not do line graph. Too many moves. Need something simple. Bar graph. There's no preview. Click on this. You got to download it to your computer. Download it to your computer. And then, oh geez, I'm in education bar. Double click it. Bam. Should open in SPSS. Why did it not open in SPSS? Try it again. Boom. There it goes. You see how quickly it's going to pop in here? It's a little slow, period. But if I'm not on there,
Yeah.
It's already up there. Okay, so there's the bar graph. I just go to graphs, bar, simple, define, here, highlight that, move it to category access, and bam. Now, hopefully I can find it.
And do you care if it's a column or a bar graph, or do you consider both of them the same?
Should look like this.
Okay, because technically, like in Excel, a bar graph is like horizontal, where the columns are
Right.
vertical.
Whatever it comes out as long as it looks like this, I'm good. I mean, in terms of the bars, we're looking for a bar graph. If it's sideways and it's a bar graph, I'm good. It shows me you know how to do a bar graph.
Okay, so then I use the same education bar data and then make a pie. Is that right?
No, that's where you're missing it. It's if you're doing SPSS, it's labeled. Give me 1 second to get over there. I can't get this to get out of the way. You see where it says stem and leaf, line, scatter, and pie.
Yes.
What are we missing?
So do each one.
There's something missing from that.
You're missing a histogram and a box plot, it looks like.
Then
Yes, that's correct.
let's not worry about it.
But what I did on mine, Dr. Jeff, is I just took one of those files and made the box plot.
Okay, great. That'd probably be the best thing to do. Pick one.
I just picked what I thought would work.
Right. So you saw what it looked like in the video. That's what you're looking for. So if I go here to back to SPSS real quick, that is not what I gave her, by the way.
Oh,
Sorry.
and actually, I'm going to tell you what I did do. I did go and look at the Excel files, and the Excel said, I don't know, like box plot, and it listed like, just say education. I'm just picking one out of the air. That's what I went and did in SPSS, if that makes sense.
Okay.
I just, that Excel data was more thorough. But I just used whatever information, whatever, like if it was education, I put it in the box plot.
All right. Well, I'll
that's
put
okay.
out later tonight. I will put out an announcement on that, because it should have said that on there, and that's what I gave it to the person for. Okay, so I will get that out as soon as I can, and that. But you can try to do any one of them if you want, and if you get a box plot, you're good. Again, it's the most important thing is you've seen what a box plot looks like. I need a box plot. I'm not asking you to analyze it. I'm saying I need to show that you can do a box plot. Does that make sense?
Yes.
And then I'll go through and I'll figure it out as soon as I get home from work, and then I'll get it out before I go to bed tonight. Does that work for everybody?
Yes.
Apologize for that. Think we're
So
gonna find-
if I turned mine in and something looks a little wonky, you'll just let me know.
I'm going to throw it away and I'm going to burn it, and
Oh, don't make me do it again.
I'm going to put it on. I'm going to put it on the internet. No, just kidding. Absolutely not. You can try and fix it now, or wait till I send out the stuff and you can do it then and just repost it. It's not a big deal. You don't
All
get
right,
the grade
great.
until it's perfect. So,
Oh, who knows? I might have done it perfect this time and then I won't have
Hey,
to do it again.
hey, there's always a chance. It's like I tell everybody, I've never had anybody turn in the first write-up perfect. I'm waiting for that person in 15 years. So hopefully it's going to be one of y'all. Okay. I apologize for anything. These are growing pains for this class. I will get that out of ASAP to you, and then we can go from there. All right. Other than that, keep up the good work. Keep working hard. You're doing fine. And make sure you're checking announcements. Okay.
Okay.
Let me
Thank
pray us
you.
out real quick. Let me pray us
Yeah,
out real
thank
quick,
you.
and then you guys can go. Heavenly Father, thank you for the day. Thank you for the patience they're having for the growing pains in this class. Lord, thank you for the good and honest questions that they're asking and pointing toward direction to continue to make this class better. Please, Lord, let them get their work done early in the week so they can all get 100% and be very solid when they walk out and they go into their DNP. Lord, please bless them as they go through the week. Keep them prosperous, healthy, and free from sin. And all God's people said, amen.
And
All right, I got to go, guys. So if you need to talk to me, feel free to give me a hot call. I'll be on the phone.